hello, everyone popping in here. It's good to see some familiar names and nice to meet all of you that are joining for the first time that I don't know. I'll get to know each other a little bit here, hanging out and chatting TMDLs and all sorts of fun, fancy stormwater topics that no one ever wanted to know about, but now, you know, if you're here, it means probably you do, right? So hopefully I can give you some good insights on these issues for those of you who have to deal with and triage these things. So my session is, navigating IGP TMDL compliance and treatment options here. So outline for what I've got for you. I'll give you a little background on myself and our company. We'll walk through I assume there's going to be kind of a mix of backgrounds in the room, right? Maybe some that are newer to the IGP and these topics and some that are more advanced. So hopefully this presentation has something for everyone there, right? So we'll talk through kind of just the permit in general, some key terminology, right? That I think you should know really well, if you're dealing with a TMDL issue. We'll walk through attachment E of the IGP. This is really where you find a lot of key information related to these issues. Kind of help you how to navigate that, how to use the IGP Map Tool, minimum mandatory penalties, updates there, talk about how you, locate some of these pollutants on your site, how you deal with them if you do have to treat for them. And then I'll do a kind of a deep dive by parameter, right? We'll look at some of the top TMDL issues, and then, how, some case studies around those that we've done, and some things to consider there. And then, I know we're talking TMDLs here, but I also had one kind of closing slide here on just other emerging contaminants, right? Things to be on the lookout for if this isn't enough to worry about, right? But, this is really where a lot of things started, right? They start as emerging contaminants, right? They work their way through a process, and then eventually they become, a concern, and then regulated contaminant, right? At this stage. So I've got the chat window open as well. If folks want to jump in and ask any questions as we go, totally fine. I'll try and kind of watch that. And if you want to save until the end, that's great too. I think you can kind of unmute at the end. Maybe just kind of, if you want to ask a question as we go, maybe just type it in the chat, and then at the end we can kind of all unmute as we like and chat. So, okay, that's the outline. So this is me. Just a little background on myself for those of you that I don't know. My name is TJ Mothersbaugh. I'm Director of Sales for WaterTectonics. I've been here for about 15 years, doing probably 3/4 of my work has been stormwater, and most of that industrial stormwater. My background in kind of biology, chemistry, and then got my MBA as well. A lot of these issues you have to deal with. A lot of technical things, but also a lot of commercial things, right? These are things that impact a company's bottom line, right? And being able to kind of get to those answers. So that's how I approach these problems, and I bring here experience. Okay. So our company, WaterTectonics, we were started in the late 90s. We design, we build, we install, we service systems, for clients across a wide range of industries, industrial, construction, municipal, et cetera. We work with a wide range of treatment systems, from simple things to advanced things. For the most part, think pump and treat though, above ground, not kind of passive underground. So we're working with customers on kind of developing solutions really specific to their applications, their site conditions, their water quality goals, et cetera. We have a whole R&D, lab services, process engineering group, applications engineering group that helps with that technology selection, validation, treatability testing, validation, of everything for a facility. And then we have a field service team that goes out and supports you, right? Once you make an investment, need that investment to work, and just like buying a car, right? Taking it in for an oil change, right? Except for oil change comes to you kind of thing, right? So, and so that is our process, right? Just kind of expanding here a little bit, right? If you're someone dealing with these issues, how we deal with them, from a customer standpoint, most customers come to me first and they say, hey, here's our water quality. We're dealing with A, B, and C. We look at that on paper. We say, yes, I've got an answer for you. I don't. We need to do more work. What is the what is the next step here to kind of get you some solutions to your water issue. From there, we often go to bench testing. So clients, will collect a sample of their water, the untreated, water, send it to us. We'll actually conduct, treatments on it at a small scale and say, hey, this is what worked, this is what didn't, this was the water quality coming in and out of process A, B, and C. These are the things we learned about it, found out about it. Here's how that would scale up to a full-scale treatment system. From there, we can do pilot testing on site for customers. So if they say, well, I don't want to quite buy something yet, but I want it, I want to spend some money to kind of invest in a pilot on my site, right? That's something we can do. We have a rental fleet of treatment systems, and we have a, SOPs and, services group that kind of executes those projects. From there, okay, you've got something fully validated, and now you're ready to go build it, right? So we do that whole design, build, install process. So we've got the engineering teams, which are process, mechanical, software, electrical, et cetera, right? All the things you need to, build a treatment system. We have the fabrication teams. We have the 40,000 square foot manufacturing facility here, where we go and we build the systems. And then we have the installation field service teams that then go out and install them on your site, train you how to run them, commission them, hand them off. And then we also have a parts and service division that supports them once they are fully installed and running for the next 10, 15, 20 years, right? And we're only like 25 years old. So I think the oldest system is like maybe 17 years, I think. About one of our first projects was actually in the Port of San Francisco back in 2003. So, okay, so that's the WT process. On to treatment technologies. So a couple different areas that we work in, right? But like I said, kind of pump and treat systems. We've got, kind of the upper area here is things I would call kind of chemistry adjustments, right? So electric regulation, chemical treatment, pH adjustment, advanced oxidation, right? These are all things where we are, typically adding something to the water, right? To get some sort of reaction, right? To change the chemistry of the water in a way that will make other treatment steps more effective. We've got kind of separation phases, right, where we're using, maybe air or tanks or plate clarifiers now to kind of settle out material. So once we've reacted it, now we need to kind of separate it into a sludge kind of phase, right? So you get a kind of a clean water and a sludge. And then you've got filtration elements. So media filters, cartridge bag filters that you then filter out. And then kind of what I'll call kind of polishing treatments at the very end. So things like ion exchange, UV disinfection, UFRO membrane treatment. These are all areas that we work as well. And we'll go into kind of some, I would say we have done all of these things in stormwater, right? On the table here. Certainly, usually not all at once. Sometimes it's just one step, and sometimes it's 10 steps, right? Depending on the complexity of the project and what the treatment need is, right? So. We've worked all over California. Like I said, kind of we're in our earliest projects there in kind of the early 2000s. Just kind of give you kind of a highlights of some selected cities here where we've done some work. So even though our manufacturing is up here in Washington, we have a lot of experience West Coast and a lot of installations down in California. Okay, so that's our background. So onto the IGP permit, right? So the latest update, right, adopted July 2020. There's always new changes in the works, right? Other changes coming, but and there's other things here in this presentation, right, that I'm not covering, right? In terms of all the updates and all the changes in the permit, but a lot of my focus here is going to be on the TMDL changes, right, that were part of that kind of the 2020 adoption. So if you're interested in things like sufficiently sensitive test methods, on-site, off-site compliance options, there's other presentations on that. And just a quick link here, right? If you are looking for TMDL resources on the Water Board's page, you can go to that link there. So the first question, right? This question is, you're in a TMDL compliance panel, right? So the question is, do these things apply to you? There's some good flowcharts out there, but to kind of walk through it, for myself, first one is, do you discharge stormwater, right? Just make sure that first. Okay, answer is yes. All right, do you discharge to a TMDL? TMDL waterway, basically, right? So for, again, acronym TMDL, total maximum daily load. This is a calculation they do that kind of says, hey, this river, water body, et cetera, can take this much load of X contaminant. And in order for us to kind of regulate it to its, human health and recreational standards, we need to allocate those resource loads across these different permitting tools. And therefore, you get a discharge limit of X and you get one of Y, et cetera, right? So you determine first off, hey, am I discharging to a TMDL waterway? There is a tool out there that you can use that I will walk you through on how to use it. It's super helpful, but it does not fully absolve you of diligence, right? So you also need to, I would say, start there and then also do additional diligence to confirm that, what you're seeing there, is also true, right? So, and then, okay, so now you discharge to a TMDL waterway. The next question is, does your discharge contain a listed pollutant in that TMDL, right? So you may go about doing this because one, you may already be testing and monitoring for it. You may need to do a site-specific pollutant source assessment. Some people rely on SIC codes, right? That may not be fully appropriate, right? You may need to do additional, pollutant source assessments and, other diligence as you advised by consultants or engineers or other stakeholders in that process, right? So kind of determining, hey, is this waterway is regulated for lead? Do I have a big source of lead on my site? I do. Okay, well, this probably applies to me, right? There's steps there to make sure that that you're doing that diligence. Okay. So a couple acronyms to kind of know here. So IGP, Industrial General Permit, TMDL, Total Maximum Daily Load, we talked about that. NALs, TNALs, and ERAs. So NALs, if you're familiar with kind of first iteration of the permit, right? These are numeric action levels. These are like benchmarks from another state. Basically, this is the goal, right? We don't want you to exceed the goal. If you do, it's not a permit violation. If you exceed the goal consistently and you don't do anything about it, that's where it becomes a problem, right? So the exceedance response action reports, the ERA technical reports, are kind of the responses to exceedances of NALs, right? And then you have a new thing here with the TMDLs, which is called a TNAL, so a TMDL-based numeric action level. So this is, okay, my previous copper, was 33 parts per billion for a NAL, and now I have a 20 part per billion TNAL. And so you still can, basically they've said, hey, we've moved your goal lower, but exceeding it still isn't a violation, right? Exceeding it is, yes, you need to go through the ERA process. You need to make a plan, right, for how you're going to improve it, and submit that plan and deliver on it, right? So the new part here is NELs, and so these are numeric effluent limits. You exceed these, this is a violation, right? So this is a line in the sand. You also have the risks here of what's called MMPs, or minimum mandatory penalties. There's a whole nother presentation on that. We'll just touch briefly on it, right? But there's different levels of serious and chronic violations, group 1 and group 2 pollutants, and something to know about, right? But basically, hey, if you have an NEL and you are exceeding it, right, realize that there's a possibility you could be subject to those penalties, which are administrative penalties from the water board, and totally independent also of any other third party legal suits or action groups, right, that may be coming after you with Clean Water Act things, etc. So this is kind of a separate lever there. When you exceed an NEL, you have a different kind of template here, what's called a water quality based corrective action, which is a little different than an exceedance response action. There are different templates, tools out there around this, right? I'll just pull up here really quick, see if I can, oh, hold on just a second. There we go. So a report template here. give you an example of one. So here's one, right? You've got info about the facility and evaluation, about the water body. You've got exceedances. You've got receiving water limitations and discussions, potential pollutant sources, evaluations, right, et cetera, right? It's a long, template. Now this is kind of one groups. There's other ones out there, but it's it's an explanation, right? Of like, well, here's how we got here, and here's what we're going to do about it, right? The last piece of this is a TSO. This is a time schedule order. So this is you go to the water board and say, hey, shield me from these MMPs while I figure this issue out, right? I want 6 months. I want 5 years. You make the ask, you lay out your, reason for it. And they say yes or no. For the most part, they're granting these, right? They want to work with people from what I've heard. But know that that's a tool out there that exists if you are subject to these things and you are concerned about MMPs, right? So, okay, all right, so typical TSO questions, right? This is an example from Region 4. Like I said, I've heard mostly from presentations I've seen from them, right? They're trying to work collaboratively with people, right? That there's likely a backlog. They're administered regionally. This isn't, at state level, but, things I've seen asked are like, okay, info about the facility, amount of time requested, are you requesting it for all pollutants or just specific ones? What interim actions are you taking while this extension is, in place? Why do you specifically need the extension, et cetera. So how widespread are TMDLs? I bet, and no one can read this tiny little slide, but I use it just as a map here, right? So there are 36 total, right? There's 3 in Northern California, 7 in San Diego, 26 in LA, 9 that have only 1 pollutant. The one that has the most is the Dominguez Channel estuary. It has 8 pollutants that are on that one, quite a few. Most of them are copper. Next is lead, then zinc, fecal, antero, total, nickel. So, just in terms of prevalence, if you're a facility with, multiple sites, across, LA or something like that, these are the issues that are most likely to pop up. So. Okay, so navigating attachment E. So this is attachment E of the IGP. This is the kind of the TMDL section here, right? And I included a link to it, so you can see here, like, here's the this TMDL, this metals TMDL. You can see, copper, lead, zinc. You can see here, this is an NEL, numeric effluent limit. You can see what the value of that NEL is. You can see the required actions. So, in addition to complying, you shall sample in accordance, with these effluent limits, collect, report data, et cetera. It gives you the date that it's due. And then just the way the tables are formatted, note that sometimes you need to turn the page on the PDF, right? Because sometimes these rows extend further down. You might miss something. And then also some of these have interim targets as well as final targets, right? So they have like, interim target is 2022, final target 2030. So I think some go out to like 2035 or something. So maybe way out there, but yeah, just note those items as you're navigating through, right? Again, if you're the end user, right, you need to find which TMDL is applicable to you, right? Confirm that you discharge to that impaired water body, watershed. Confirm that you have that pollutant in your pollutant source assessment. Confirm that you exceed those values for that pollutant at those levels, or have a concern about maybe exceeding them, and then see what those required actions are and when you need to meet them. So. Okay, so IGP Map Tool. I will show you this, and I'll see if I can get kind of a split screen going here. So this is a great tool that I included the link here, and I'll just put it in the chat too. I'll do that here for people in case this doesn't go out. Okay, there you go. And so you're a site, right? You enter in your address. Note that when you first enter in your address, So you click the link above, enter your site address, and then click somewhere on the orange to deselect the site, because when you first do it, it's not gonna select it, right? And then click the dot again, right? And you'll see your address. Okay, now it says search result 1 of 5. Okay, now you're on the right spot, right? Okay. Now click through the arrows, right? And you will kind of see these additional pages, right? So I could, okay, I click page 1, page 2, Huck 10, Lower LA River, page 3. Oh, Los Angeles River Nitrogen TMDL, LA River tributaries, LA River Metals TMDL. Okay. LA River Nitrogen TMDL, LA River watershed, etc. Right? So this is where you are. You have your address, right? You click through, and now you can see, you know, pretty quickly what you know, which things you need to go look at back in that attachment E. And say, okay, I need to go look at the LA River Nitrogen TMDL. I need to look at the LA River Metals TMDL and see what those things say, right? And then know what my actions are. So included the kind of instructions through there. Continued, right? Click through the tabs, etc. Okay. Okay, so the next one is the minimum mandatory penalty. So let's say you, you know, you're just going about your day, and you're not one of the people who attended this webinar and don't know what's going on, right? You get a letter, right, from the water board, presumably, you know, if you exceed these. These have just started to go out, you know, in kind of the first half of this year, from what I've heard. So like this is some data from a Region 4 area. What if your site is half in a TMDL and half out? Ooh, good question. If your site is, I would assume if the half that discharges to the TMDL would be relevant to it, and if the other half doesn't, but if the whole site discharges to one, I've never heard that question. My general response would be, if there's even a little bit that discharges, then probably the whole thing would apply. But you know, probably a good question for, you know, lawyer or regulator as well, right? So, but yeah, haven't heard of that use case yet. Okay, so Region 4 issued some of these letters here in early 22. I know the kind of a first batch of about 49 facilities they sent out, and other regions, right? They issue these regionally, you know, as well as I know Region 4. Again, most of the TMDLs are in LA region, right? So that's where they're going to come from, a lot of them. You know, and there's more batches coming as well, right? So I was going to kind of, if anyone hasn't seen or received one of these letters, I mean, hopefully you haven't, but I did kind of a blacked out version here, so so folks can kind of see what this looks like, right? But right, so I'm right, I've got this certified mail, wonderful, from the water board. Hey, you've got an offer to participate in an expedited payment program due to violations of the water quality, you know, state board. Here's your notice of violation. Here's your liability and the codes. You know, we could charge you $25 a gallon, blah, blah, blah. Here's the payment program where you send us your money. Correct. You also, reminder, you also need to submit this water quality based corrective action report. That was the WQBCA we talked about. Remember, we got this data from Smarts where you uploaded it. You also have other options. You can choose to respond to this and fight it if you want. And here's how we get to resolution, etc. Here's where we tell you, here's the exhibit of your violations, you know, what they were, what the penalty is, and these can stack. And they can stack per outfall, per pollutant, per instance, and they can start stacking, you know, pretty significantly, right? You know, they got the lowest possible one here for a single outfall, single pollutant, you know, single hit. Again, resolution, right to hearing, et cetera, et cetera, et cetera. So, right, that's one of the things that can be on the horizon for you there. Link you can provide to an accurate and current river reach map available through the board. Disregard if we are to just use the GIS map tool. Yeah, I don't know of one outside of that. I'm sure there are. You know, that's the one that I use when I am kind of working with folks, and then, you know, just to see like quickly, does this, you know, I would say 90 to 95% of the time it's right, you know, but just anyone's lawyer will also tell them, and make sure, don't trust just that tool. Confirm, hey, hydrologically, it says that I should be here, but I confirm that the pipe from my site actually goes over there, and is incorrect, on your map tool. And here is a memo from my engineer and lawyer and GIS and camera survey we did, right, that shows that, right, something like that. So hope that is helpful. Okay, back here, it's big again. So there you go, MMPs. So that's right. That brings us through TMDLs. So now I'm just going to kind of talk about, now is dealing with these issues, right? Well, first off is, do you have these issues, right? What are all the sources of these contaminants? Well, they could be something you generate, on your site, right, through activity that you do industrially. You could get them from offsite air deposition. Could be from trucks carrying them onto your site. Could be some background soils, below your facility. There's all sorts of places these contaminants could come from. They get mobilized, right, through the rain, right, sheet flow, through drains, right, to your sample point. And then you take a sample and you get a hit, right? Treatment, right, before you get to the pump and treat world, right, basins, passive, source control, maybe you try and go zero discharge and reuse it, or use some of the on-site compliance options out there and infiltrate. Maybe you try and send it off-site to a sewer. And basically most people I've worked with have tried all of the above, right, by the time they get to active treatment or pump and treat, because it is higher cost, right? And it is, but it's also high cost to do a bunch of things that don't get there too, so I think that's, my goal is when I work with a client before they've invested any dollars, right, is to just say, we can look at the water, right, the water profile running off your site and make some pretty informed guesses, right, about what's going to work and what's not, right, based on that water quality data. And I'll talk through that here. So when we're talking about these pollutants, getting out of the water, I like to think of really 4 ways that happens, right? It settles out, it gets filtered out, it gets absorbed into something or adsorbed onto something. And most world of treatment options here are some variation of this. Right, gravity. Let's say I just put a pond out or a basin, right, or a vault underground. What am I relying on? I'm relying on gravity, right? That hopefully these particles in my water, that the pollutants I'm concerned about are associated with those particles, and that those particles can settle out in time for my treatment to work. And I can do math on that to solve that equation and tell you it'll work or it won't, right? If something takes 1,600 years to settle out, probably not going to work. Takes, a couple hours or a couple minutes, okay, maybe it's viable, right? But knowing what size particles you have and whether or not the pollutants you are dealing with are associated with those particles, right? That's going to tell you whether or not gravity is going to work. Step 2, filtration, right? So filtration can be anything from that sock sitting on your catch basin to reverse osmosis, right? Like all of these things are just tighter and tighter levels of filtration that are saying, hey, I am pollutant A, I am preventing you from passing through this membrane, this field. And all of these have different, pros and cons to using them. And all of this material that you're building up, right, still has to be, removed, cleaned, backwashed, segregated, etc. Right? All I'm doing is I'm concentrating my, undesirables, right, into a different stream than my desirables, my treated water. Absorption and adsorption. So absorption, I think of as like, something, my pollutant going inside of something, right? So I think this is more as like living systems, like plants uptaking something into their tissues. And adsorption, I typically think of more as like a resin or a media that is going to kind of bind that contaminant to the surface of that compound, right? And so, there's different design standards for, don't really work in the living system side, but on the adsorption side, right, there's a lot of different design standards here, depending on, what the target media is, what's its capacity to adsorb pollutants, can they desorb, what flux rates do you need, what flow rates do you need, does it want to grab X instead of Y, if something else is in the water first, you know, there's all sorts of different design considerations there. So these are kind of the three big drivers, right, of active treatment. So we talked about first particle size, right? If I have really small particles, it's going to be really hard to filter that out or settle it out or do something else, right? I'm likely going to need to use some chemistry and coagulate, basically get those small particles to be larger particles, so then I can get them out with one of those easier methods. Dissolve metals, right? So if I have metals, and we'll do some metals case studies, and they are in a dissolve phase. What does dissolve phase mean? Well, technically, if you're analyzing it at the lab, it means it's just something that's under 0.45 microns. It just means it's really small. Could be 0.43 microns, could be, you know, 0.0001, you know, elemental zinc or something, right? But when you adjust pH in the water, most metals that we're concerned about are going to have a solubility curve. And so you look at something like zinc, for example, which is this dark blue line here, and you can see, well, at a neutral pH, I can have up to like 70 parts per million of zinc that can stay in the water in kind of a soluble form where you couldn't see it, right? It could look like a glass of water. And then as I raise the pH, that zinc is going to react with the excess hydroxides, right? The OH groups that are in the water because of that higher pH. And less of that zinc is going to be able to stay in that soluble form. It's going to react with those hydroxides until you get down to this pH of like, you know, 9.5, 10. And now only 0.1 part per million of zinc can stay within. And the rest is going to precipitate out as this zinc hydroxide, which you'll be able to see and like grab onto and coagulate and filter, right? But if I'm up here and I've got a, you know, maybe even like a slightly acidic water, and it's all dissolved zinc, and I'm trying to run it through a filter, right? You can see why that's not gonna work, right? So, and then other specialty contaminants, right? Things where BOD, COD, you know, anionic, you know, negatively charged things that are non-charged, nitrate, etc. You know, things I'll just put in the specialty contaminants category, right? That require all sorts of different treatments to address. Okay, so when we're thinking about a treatment system, okay, you figured out, you've got an issue, you know where your stuff is coming from, you know the world of treatment options that are available to you. Now, how do you go about designing a system for your site specifically? So a couple things that I'd advise people on, right, when you're working on these things. One is, what's the design criteria for my system? Do I want it to be able to handle just like the most recent sample that I saw? Do I want it to be able to handle the worst sample I've ever seen? Do I want it to handle something, you know, worse than that even, you know, because I'm expanding my operations and I'm going to be doing all this new activity and, you know, something else, or I know of some new pollutant that's going to start being regulated soon, right? Those are all, what is your design criteria? What are you asking your vendor or your consultant to build you a system to do? What do you want that system to handle? So then the next part is, okay, here's the system. And you build some system and it has some mix of kind of fixed and variable things. So an example here is like, well, I put in a tank and the tank is 10,000 gallons. I can't change that. But what I can change maybe is how much chemical I dose for every 100 gallons a minute of water I process, right? Thing that I can toggle up and down. And so you want some flexibility there in your design where you have some fixed and variable inputs so that you can, you know, adjust to the variability of the stormwater you're trying to treat, right? And then the outputs from your system are presumably clean water, right? And some sort of waste or sludge, right? Somewhere where you concentrated the undesirable, you know, components in your water into some sort of stream that you can dispose of elsewhere. Okay. So metals TMDLs here. So selenium, nickel, cadmium, mercury, copper, zinc, lead. You know, quick highlights on these, right? You know, selenium, extremely difficult. If you're dealing with this, one of the most difficult pieces out there. Nickel, it can be difficult at low levels. There's not a lot of folks dealing with it. Not a lot where it that have it in their effluent initially. Cadmium, I see that a little more. Again, it's low levels. Not a lot of data though. Mercury, it's a very low target. That's a tough one. Again, there's just one. Copper, right? This is the most common one. We've got tons of data on this. Lots of sites that have it. Yes, there are low targets, but I'd also say, yes, there are lots of options too. Similar with zinc, although we found most often the case that pH adjustment is one of the best pieces there. A lot of zinc will want to stay in that kind of soluble form. And lead is, I'd say, one of the easiest ones, right, to address, just given its solubility curve and its receptivity to treatment. So if you're kind of at the top of the list, like this is the worst one, this is the easiest one, in my opinion. So I'll just do two quick kind of little case studies here. So this was one where this is an example, right, of kind of particle size plane issue, right? So the customer, they installed a settling basin, an oil water separator, and a media filter, right? And they got from kind of basically the blue line to the orange line, right? They reduced things, you know, anywhere from 50 to 80%, but not nearly enough what they needed to, right? And so when they did an analysis, they found that, you know, pretty good majority of their water had, you know, particle size, you know, under 10 micron, right? And that media filter they put in was only doing 20 micron, right? So all that 10 micron stuff just flows right through, right? And carries all those contaminants with it. So once we retrofitted that system, we added some chemistry up front and some settling tanks, you know, used the same media filter they had. We were able to get those things down, you know, below target there. On the dissolved metal side, right, I talked about, you know, that pH factor, right? So here's a case where, gosh, this water, okay, it looks a little kind of stained, but it doesn't look that dirty, right? But you adjust the pH, and now you see all of this material react with that higher pH and now pop out a solution, right? So this was actually pretty high in lead. We adjusted the pH, that they reacted, right? We got that lead hydroxide flock out. We filtered it. Now it was non-detect. Even though this one actually kind of looks similar to this one over here, right? You know, still kind of stained a little bit, still a little colored, but you know, all that lead is gone. So. You've got the organic TMDLs. So these are PCBs, PAHs, chloridane, dissolved methyl mercury, 4,4-DDT, dieldrin. You know, these are super rare to encounter in my experience. Haven't encountered them much on these yet. PCBs, PAHs more common. PCBs the most common. You know, a lot of kind of old, you know, DoD kind of sites we've done cleanup work on, some aerospace stuff. You know, here's two different facilities we've worked with where, you know, they were targeting a, you know, this is 0.014 parts per billion, right? So that's getting to some low numbers, right? If you're tracking, you know, these two sites discharged to two different areas. This one actually discharged to sewer and had that low of a number. This one discharged to storm and had actually the same number. And these were also on different coasts as well. Different interesting case there, right? But you know, again, I'd say PCBs, the most common one you're going to encounter in these organic TMDLs, and pretty treatable, achievable. Just, you know, very low limits, right? And have to be diligent with maintaining your systems there. Nitrogen TMDLs here. There's nitrate, nitrite, N plus N, nitrate plus nitrite. There's ammonia, there's nitrogen, which is all three of these. Highly soluble in water, very difficult to deal with. Definitely need some sort of targeted ways with significant upfront pretreatment. I'm going to kind of group these next three into kind of the same category and then do kind of one case study on all of them. So got a site that's dealing with all three of these next TMDLs. Phosphorus, right? Very low levels. You know, compared to other, you know, permit targets, right? You know, magnitudes lower typically. Difficult to precipitate out, difficult in its dissolve phase. And then bacteria TMDLs, so things like fecal coliform, entero, total coliform. You know, lots of options here, right? You know, disinfection, right, of water is something we do in drinking water all the time, right? Sort of widely available, commercial scale. A lot of the challenges are with, you know, flow intermittence, right? Stormwater is not flowing all the time, like kind of drinking water plants are, and so they can have a steady state process. Stormwater, you don't really have a steady state process, so that's more of the challenge, is just managing growth, you know, bacterial growth in between events, and making sure that you keep that down. So this is a case where a site that has all three, right? They've got an N plus N issue, they've got a phosphorus issue, they've got a bacteria issue, right? So transfer station, you know, pretty typical site here that would be dealing with all of those things. You can see here, right? So this is the influent water, and then this is after what we'll call kind of our second stage treatment. Already looks really nice, right? But after that, we still needed 3 more layers of treatment to kind of get to final goals, right? So We dealt with all of the TSS, the metals, the COD through, that first step. And then we needed separate polishings for the phosphate, for the nitrate, and for the disinfection for the bacteria there. Now, I would say it's a pretty conservative design, right? They were sometimes meeting their requirements, at just after that second step, depending on the flow event. But some of these facilities, right, under a lot of scrutiny, and they wanted a design that felt very, very rock solid. So that's that's what I have for the TMDLs. But I'd also say, right, there's a whole other world out there of emerging things, right? How things started and then ended up right on your TMDL list as they were at one point emerging. Emerging, by the way, doesn't really have any federal statutory definition. It's just kind of a term used to refer to unregulated substances, right? That people have said might pose a problem someday, right? Like currently, EPA has 12 different fact sheets for what they consider their emerging contaminants. Probably the one you hear about most, in the news these days is PFAS issues, right? But I don't know if anyone else is in this room, right? I might have also just seen California kicked off their microplastics monitoring, which is a huge deal. One of the first places in the world to do a program as extensive as they're doing there. Up in Washington, 6-ppdquinone has been identified as probably maybe one of the biggest toxic elements to spawning fish, which was a previously kind of unknown compound at all. You also have things like tungsten, which is like, what, tungsten? Yes, that's one of EPA's 12 emerging contaminant fact sheets there. So the thing I ask in emerging is, hey, is this something that's new to the world, right? Is this like a totally new contaminant in general that no one ever knew about before? Is it something that's just being, regulated to new levels? And so it really requires a whole new suite of solutions and answers to address it? Or is it something that's just new to you, right? The world has lots of solutions for this, but now it's being regulated in stormwater or in stormwater in this waterway, et cetera, right? And where those things overlap, is kind of the thing to kind of be mindful of there. Okay, so, and I was just gonna, on the last slides here, I kind of want to leave time for questions, but I was just gonna highlight, probably the biggest issue, right? The PFAS one. So if you're in California, right, this isn't in the most stormwater industrial general permit areas yet. There's no TMDL for it, right? But it is where a lot of the national and state level attention is going, right? So they've got this PFAS heat map in California. They're looking at, airports, chrome platers, DOD, landfills, water wells, refineries, et cetera, right? San Diego has their own board where they're looking at 21 different sites that they're concerned about. We've done a project up here in the NorCal side, where there was some significant firefighting activity. One of the big sources of PFAS is that AFFF firefighting foam, right? And so they've had to deal with this for a few years now. We helped them kind of develop some solutions, put out a treatment system. They were dealing with PFAS levels, in the thousands, right, of nanograms. Again, we're not talking micrograms now, we're talking nanograms. We're talking, very low levels of where these pollutants have a concern. And also when you hear PFAS, realize that it's something that has, it's a class of 5,000 different compounds that's ever expanding, right? And so the most common ones are the PFOA and the PFAS are where a lot of the attention is. And so like on this site, here's their influent and our effluent. We've got, PFOA as the main regulated compound. They are targeting a 40 nanogram per liter limit. You can see here in our process, we have a pre-treatment followed by different stages of lead leg, polishing, carbon and ion exchange resins. Our carbon, takes out, goes from, many thousands here down to, some hundreds. And then our lead ion exchange PFAS vessel takes it, usually below the limit. Actually, it's always been below the limit. And then the leg takes it basically non-detect, in perpetuity. So there's a lot of solutions out there, if you're concerned about it, right? the great joke or not joke about PFAS is, if you sample for it, you'll find it, right? Because it's everywhere. And the levels that they're talking about and how pervasive it is across the environment, right? So I expect this to filter into stormwater issues, right, and water issues in general, right, as things continue to expand. So, all right, that brings me to my 45. My contact information here, and if anyone has any questions, I guess we'll open it up, Rebecca. So, yeah.
If you have any questions, y'all, just go ahead and put it in the chat. You can send TJ some of your questions from the workshop. Thank you, TJ. This was very informative. So awesome to have you part of Stormwater Awareness Week, and very grateful for everyone who's joined us today. And if you missed any part of this workshop or any of the other workshops, you can find the recording up on our website. It will be up in about 24 to 48 hours, and you can go to the recorded workshops page on our menu, and you can see all the workshops there. So anyone have any questions? They either want to unmute themselves or put it in the chat.
I'll just look back through the chat window here for a minute, make sure if there was any I missed. I know I tried to kind of answer some as we went. Oh, okay. Just one person here mentioned I contacted my city and they got me an exact map of where rainwater goes. Okay, yeah, it's a good note, Todd. For I think someone else was asking about that, about saying, hey, whether resources are out there, right? Beyond that IGP Map Tool, your local municipality, city, county, et cetera, may be able to provide you some additional insights on that.
Awesome. Well, thank you so much. And we hope you all enjoy the rest of Stormwater Awareness Week. And we have one more class for today, which is going to be on how compost-based MMPs help California cities meet their organics diversion requirements. And that starts at 3 o'clock. So if you want to head over to the website, you can catch that. If you haven't registered, and if you have registered, go find the link to that workshop in your email. So thank you, TJ, and thank you everyone for joining us.
Thank you so much.